A purified enzyme shows a single 60 kilodalton band on SDS page under reducing conditions, but shows a band at 120 kilodaltons on native page. Which conclusion is most supported by the data? Leave a comment what you think the answer might be. Here's an image showing the results described in the question. And on the right side, I've drawn a representation of an enzyme with two subunits. When proteins are ran in a gel under native conditions, none of their bonds are disrupted, so while they're in the gel, they'll be in the same form that they are in the cell. So if our enzyme is made up of two subunits, then those subunits will stay together as it migrates through the gel under native conditions. However, when we do the SDS reducing conditions, all intermolecular forces are broken up by the SDS treatment, and disulfide bonds are broken up by the reducing conditions. This means that any subunits that make up a protein will be broken apart because subunits are always connected by intermolecular forces, and then sometimes there are also disulfide bonds that keep them together. So if both of those are disrupted, then the subunits can't stay together. So then when that protein gets ran through the gel, the subunits will be traveling separately. And a lot of times what this is going to result in is having two bands in the reducing condition, because the subunits are often different molecular weights. But if there's only one band, like what we have here, that means that our subunits are the same molecular weight. And most of the time, this means the subunits are identical. Now, just because there's a single band doesn't confirm that we only have two subunits, so we have to confirm that using a little bit of easy math. If the protein in its native state weighed 120 kilodaltons, and then we have one band at 60 kilodaltons, we know that all the subunits weigh the same. So then if we combine two of them, we would get a full protein that weighs 120 kilodaltons. So we know that this protein has two subunits that weigh the same and are likely identical subunits, which means this enzyme is likely a homodimer. And that answer lines up with option B.